I see from the list that all of the presenters are local. Okay. Okay, good afternoon, everyone. My name is Masra. I'll be chairing this afternoon session. So we are one of the last two sessions, okay, before the closing ceremony. So for this session, we have 6 presenters. So each presenter will have around 20 minutes to present, and including Q&A. Yeah? And since we have closing ceremony exactly at 4:30, so hopefully we don't go beyond the time lah. Yeah. Otherwise, we will miss the closing ceremony, and one of you could be could win the best paper award. We have that during the closing ceremony, yeah, Dr. Alfred. I'm not sure. I'm just saying, okay, just to make sure that we don't go beyond 4:30, inshallah. Okay. So since it's 2 o'clock already, I will do my presentation first. Yeah, it's unfair that I'm sharing the session at the same time I'm also presenting my paper. Can I have Dr. Sarah, the second presenter, to look after the time? Is that okay?
Sure.
Okay.
20 minutes, right?
20 minutes. Okay.
Okay.
Let me know if I go beyond that. Thank
No
you so
worries.
much. I will share my screen now. A window. Okay. Hold on. Right, I have issue with my MacBook here. Just hold on. So sorry for this. Let me try again.
It's okay. I haven't started the time.
But the time order is running. Okay, screen recording. Okay, so I think I have some issue here with my MacBook because it doesn't allow me to somehow share because we are recording the session, is it?
Yeah, I think Dr. Rainer recording the session.
Okay. Right. Yeah. Dr. Sarah, can I ask you to go first? Is that okay? So sorry.
Oh, okay.
I
Let me
will
try.
I will
It's
need
okay.
to get my other notebook. Hold on.
Okay, no worries. So I'm presenting first. Wait, hold on. Let me try to choose a window. Oh, sorry. Window. Okay, is it showing? I'm not so sure. It seems like it's still loading.
It shows perfectly fine just now.
Then what is it now? Is it my face?
Yeah, now it's showing you. Just now it shows your slide.
What happened? Wait, hold on.
Okay, so now we're not having smart technologies anyway, so nothing is reliable at the moment. It's okay, take your time.
Okay, let
So
me
we'll do
try.
our best to complete by 4:30. Yes. Thank you. Go ahead. Yeah.
I will stop my video because sometimes it's changing between my video. Okay, so good afternoon, everybody, especially to our chairperson, Dr. Masra. So today I'm going to present our paper on social versus physical distancing, an analysis of public health messages at the start of COVID-19 outbreak in Malaysia using natural language processing. So this is a work between Felix and I. We are from a computer science faculty and also from the cognitive science and human resource development faculty. So let me begin my outline of the presentation. So basically, I'm going to talk about what's the motivation behind this study, as well as what is it about social media analytics, just a brief info about it. And then what's our status COVID-19 pandemic in Malaysia as of end of July, and our proposed work, which is the Linguistic Analysis Framework for SMA or Social Media Analytics, and then I will present my results and analysis. Okay, so just to introduce a little bit on what is it that we're trying to do is that right now we are looking at social media is being used for communicating with the public by the government to the people. So we see that there are specific syntax that is being used, and they are emerging in order to send communication, basically giving health messages to the public, and the public as well are discussing using the syntaxes. And so there are some studies about communication issues during previous pandemics such as SARS, H1N1, but however they have not been investigating the substantial role of social media, especially how it plays during the pandemic. Is it really helping to give the right communication or the right message to the public, or are the public exactly understanding all the syntaxes or all the health messages that are being circulated? And uniquely in Malaysia, we are multi-ethnic and also multicultural group, multicultural country. So we practice different beliefs and also values, and we have different languages. So the way that we see the Malaysian government's way of communicating to the public is a little bit unique, because they must make sure that all of the communities, talking different languages, are being, they are giving the right messages. So they have to prepare various different types of messages that should relate to the same meaning or the same message. The key points are there in different languages. And so this is a challenge to the country, actually. So we want to start about looking at how we can do some linguistic analysis of social media interactions, as it becomes a necessary for the government to design and deploy public health messages, and to share and also educate the public using social media through public health messages. So the aim of our paper is basically to examine how the social media users in Malaysia use social distancing and also physical distancing. So we are using these two key terms, and how they use it in their social media posts. And also we want to capture the public sentiments on the new norm in the last 19 months, which means we started in January last year, 2020, until 31st of July 2021, by using computational linguistics tools. Basically, we want to process using natural language processing. So maybe a little bit about what is social media analytics. So of course, we know that social media is actually a platform where the public, people like us, communicate with people, talking about anything. We just share everything on social media platform. And it is heavily being used, especially during this pandemic. It became the main platform for organizations, institutions, education institutions especially, to communicate to the public, to the community, to their workers, to their students. So it is being really heavily used by the public. Now we're going to look into what is social media analytics. So SMA is basically talking about how we gather the inputs from social media platforms. So we can use existing APIs, social media APIs, and to crawl the data and to make decisions and recommendations after we understand what kind of data that we are dealing with. So how SMA is being applied in real world is that we can see that there are companies that have used SMA to understand consumers' needs and also observe their reactions to products and services, and as well as to investigate uh, social media users' perceptions on certain crises, like political crisis in Turkey and Syria. Also, recently, last year, basically our work is based on this motivation, where uh, in Australia, they tried to investigate the perceptions on social distancing during the COVID-19 outbreak using the Twitter data. So, however, in that study, in the Australian study, they did not mention about physical distancing. They only used social distancing. However, we understand that physical distancing is actually the right word to use, because we do not want people to feel socially distanced. We just want them to be physically distant, between themselves. So WHO, or World Health Organization, has already, set out in their guidelines to use physical distancing in their public health messages after there was a call to rebrand social distancing. And so there's a gap in that study, and we are using both social distancing and also physical distancing in our study, and to study based on Malaysian social media. Okay, so the basic concept of SMA is basically we look into how we can capture the data using various tools or various ways, and how we can understand as well as presenting the data. So the most important one is the part where we need to know what is the best way to capture the data and what is the best way to understand the data. So basically we can use NLP tools to understand the data through understanding the sentiments using sentiment analyzer, understanding the data using n-gram approaches, or various other techniques available in research. Okay, so presenting would be understanding what did we find out. Okay, we look at the trends, we can look at the word behavior, how it behaves in the social media data. So let's look at the scenario before we go to our proposed work. So this is basically the scenario of COVID-19 cases in Malaysia. I believe we are all Malaysians here right now. So we started the pandemic started in January February there were like about one or two cases, but the outbreak started after a religious gathering in Sri Petaling as well as in Kuching that took place in early March 2020. That's when we had our MCO, the first MCO, and then after we had our first MCO, we started with the government extended the MCO 2 until 4, and then we had a CMCO, which is the conditional MCO, and then we have the recovery MCO. However, the cases are still increasing, as you know, as of today. And so, how do we actually use the social media, for communicating? So this is something that we have to put ourselves and try to question and then try to answer it. So this is just the basic, just a brief scenario on what we're having right now. So we're going to compare our results later on with these COVID-19 cases. All right, so now we're going to what we propose, which is the linguistic analysis framework for SMA, basically how we conduct our SMA. So first, of course, we are based on the basic concept of SMA, which is the capture, understand, and present. So how do we capture it? So we understand that we are looking at Malaysian social media data. So we anticipate there will be a multilingual data that we will be crawling. And so we have to understand that there will be multilingual terms. So we understand that we are using social distancing and also physical distancing. And therefore, we need to actually include the translations. So right now, we are just using the Malay translations. And we try to understand what are they talking about on these two terms, okay, using these two terms, social distancing and also physical distancing. So we try to mine our social media data based on the timeline and also the location of the users. So after that, we try to understand what do they say, the social media data. So basically, we are using NLP tools So we analyze the trends based on the frequency and also the timing of the posts. And then after that, we proceed with linguistic analysis by looking at the syntax. Syntax here is more on the word behavior, how it behaves based on the co-occurrence of the words. Okay, so we're looking at word pairs. And semantically, we look into the sentiments. What are the public sentiments on the social media data? And then after that, we try to present to understand further what did they try to discuss. Okay. So this is our work. Basically, how we capture is that we extracted Twitter data from pre-MCO, which is starting from January to 2020, to post-MCO periods, which is we stopped until 31st of July 2021. So it's 19 months of social media data. So we use these 4 key terms: social distancing, physical distancing, penjarakan physical, which is actually the translation of physical distancing, and also penjarakan social, which is the translation of social distancing. So we are expecting multilingual data when we extracted the Twitter data. So the fees are only in the Malaysian region. So for now, we use a scraper called SN-Scrape. It's a Python module. It's free for use, open source tool. Actually, SN-Scrape is quite new. I think not much benchmarking has been done, but I do believe that they are really useful in extracting data. I think there are some users that have used to extract Facebook data as well as other social media platforms. So after that, after we gather the Twitter data, to analyze the social media data, as I mentioned before, we want to look at the trends based on the frequency and also the timing. So we look at the frequency as in like how many times social distancing is being mentioned in each of the posts. Then we try to look at how are we going to compare the trends, because the numbers that we got are really huge in terms of the range. So we have to normalize it, and we propose to use normalized frequency using min-max feature scaling, whereby if you want to normalize, let's say we have this 108, well, this social distancing is appearing 108 times and in that particular month, and so we try to normalize this value to get 0.189 by using this formula. So you will see later on that we get some trend. Okay, besides looking at the trend, we also look at the word behavior. So we want to look at how people actually speak about the social distancing, talking about social distancing in the social media posts. So we use N-gram approach to see the word occurrence as well as the word behaviors based on the word pair, and also to discover some, maybe there are possibilities of people doing code switch. So code switch, just a brief about what is code switch. So we have an example. This is extracted from the Twitter data. So we can actually see that this is a Malay sentence. However, there are also English words in it. So this is the difficulty that we face. We do not know how to classify whether this sentence is it actually an English sentence or a Malay sentence from using the NLP tool. So we are proposing another method to do on the sentiment analyzer. So I'm going to go to that part. So after we discover that there are code switch data or multilingual data, so that's where we have a problem on how to do sentiment analysis. We cannot only use a sentiment analyzer that is only specific to Malay language, because we also look at there are also English sentence with Malay words. And so we came up with this hybrid approach whereby we are using existing NLP toolkits, open source, called Polyglot and also Malaya. So both of these are actually NLP tools, also Python modules. So Polyglot is actually not only a sentiment analyzer, but it's actually offering other features like morphological analysis, language detector, and etc. The models are all built using Wikipedia data, huge, large data sets, 136 languages. However, because of our data is actually social media data, more informal words, and therefore this polyglot is not really suitable if we only use it to detect the sentiments because it's built on formal data, which is what is written in the Wikipedia. And therefore, we found this Malaya NLP, which is Malaya NLP Toolkit, also free Python module, also having some brilliant features like morphological analyzer, sentiment analyzer. However, they are built specific for Malay and also for English. And this sentiment analyzer, they are being trained using social media data. However, as I mentioned again, it is only being built on Malay language. And therefore, we have to use these two NLP, and we use a language detector from Polyglot to determine whether we are looking at an English sentence or is it a Malay sentence using the scores of the language detector. So once we detect that, then we push it to the correct, basically the preferred NLP approach. Either we're using Polyglot or Malaya. Then after that, we get the sentiment scores, and then we use the sentiment scores to come up with the sentiments, positive, neutral, or negative. So all these are done automatically. All right, so after that, on the understanding the data, so we come up with how we should represent the findings. So we have the trends as well as sentiments, and also we are going to study on the code switch data or multilingual data. All right, so now we're going to the results and analysis of our preliminary finding. So based on the trends, if you would see here, we have extracted around 7,078 tweets from last year to 31st of July. So from here, we see that social distancing is the top term being discussed in the social media. Physical distancing, however, you see that it's not really, a popular trend, even though that is being practiced in the WHO guideline. If you see from the even the translations, you would see that they have the similar trend. Penjarakan social is being favored compared to penjarakan physical. And if you see based on their peaks, so you would observe here, if you can see from the observation here, we can see that the the distancing is being discussed in the earlier part of our pandemic, and then it begins to die down. So you will see that the rest are also dying down as we go to our second year of the pandemic. And we also plotted based on the cumulative confirmed cases, as you will see that the cases are rising. However, the discussion on social distancing and also physical distancing are not as frequently being discussed as the cases are being is rising. So this is something that we would like to understand. Why does this happen? Are they discussing something else like vaccination or something? So this is something that is interesting that we see from our social media data. Besides that, so we look at the bigrams. So the bigrams is the one that we want to study on the word behavior. So this is where we discovered there are code switch data as we divided the findings, our results into English, Malay, and also code switch. So you would see that there are terms that they are actually similar. However, they are being code switched. Like for example, we have pakai mask in code switch data here, and we also have wear mask. So another example here, we also have jaga social. So basically, we have it is actually semantically similar to practice social. So this is where we see that we have Malaysians that we have the tendency to code switch when we write. So we have this problem when we use NLP tools, especially the existing ones. We have to be very careful when we want to actually use them because they might not be suitable with our multilingual data. All right, so besides that, from the bigrams, we also looked at how the word social is being connected, or maybe other words are being connected to other words in the social media. So what we see is that the word social has the most linked words. So I think it is as many as 10 words that are connected to social. So it means that the public are actually talking about social distancing, and then they also talk about they need to stay social to do social distancing, wear their masks, and etc. So this diagram shows that the public health messages or the discussions that people actually talk in Twitter are basically talking about taking care of themselves, all right, keeping themselves, practice social distancing, and also practice the SOP. So these are basically the discussions that the public have in the Twitter data. All right, so now we go to our last analysis, which is based on the sentiment analysis. So these are the results based on our hybrid approach strategy that we proposed before. So we will see that the overall, the public actually reacted negatively through social media when they actually discussed about social distancing and also physical distancing. So we see that it is actually happening based on both translations and also in the English words or the terms. And another interesting one is that the opinions on the physical distancing and penjarakan physical, however, are different, although they are semantically similar. If you see here, physical distancing has about, let's say, I would say about 98 saying that this is positive. However, on penjarakan physical says that it is 187 negative. Okay, so
sorry to intro, Dr. Sarah. You have
yes.
2 minutes left.
Okay. Yeah, I'm about to wrap up. Thank you. All right. So I would like to say that the findings that we have are not being validated yet by human experts. These are actually automatically generated from the sentiment analysis. So with that, I would like to conclude what we've already done for our research is that we want to look at how actually public are discussing about social distancing and physical distancing in the social media. And we are proposing a linguistic analysis framework whereby we want to try to use this framework to analyze the social media content in the environment of Malaysia, in the Malaysian context. So from there, we came up with a hybrid strategy to automatically analyze the multilingual data, as we see that the public applied code switching when discussed about social distancing and also physical distancing. And last but not least, we would like to say that based on our findings, we found out that the public reacted negatively through social media when they discussed about these two terms, social distancing and also physical distancing. We also published the data on this link. You can actually scan it to get to the GitHub. So we published the 7,000 social media data that we've already processed with the sentiment levels. So with that, I thank you very much.
Thank you, Dr. Sarah. It was a interesting work that you do. Yeah, I mean, it's also interesting to know what you're going to do when you analyze, why public react negatively to the two words, social distancing and physical distancing. Any idea, do you have any idea if the public know the difference between these two terms? Just curious.
Whether they understand between the two terms. I haven't got into that level yet. What we can observe is that they are not aware that they are not aware that WHO has already emphasized that in the guideline to use physical distancing. So that is why I'm not so sure who to blame. Who keep on using social distancing. So this is something that maybe we would like to further research about that.
It's also best if we can include the distance measurement. Yeah, so some may not be aware that the distance is a minimum of 1 meter, for example. Okay, because if you see that in other countries, they have 1.5 meters, so they have 2 meters. But in our country, we use 1 meter. But I think 1 meter is quite close juga lah, compared to other countries. Okay, thank you, Dr. Sarah. Again, any questions from other members? Any more? Okay, if there are no questions, then I would like to try again during my presentation due to technical error just now. I'm so sorry that I have taken a few minutes of the time. So let me try again, okay?
Okay.
Thank you.
Thank you very much. Yep.
Okay, so this time I would like Dr. Sarah to look after my time, yeah?
Okay. Let me try.
Okay, hold on. Okay, right. Let me continue with my presentation. Assalamualaikum warahmatullahi ta'ala wabarakatuh. A very good afternoon to everyone. Yes, Alhamdulillah, I managed to get my slide up. Right, yeah, before that. Okay, so I'll be presenting a very small scale of work. Okay, this comes from a large project, but basically my focus is on looking at the learner's perspective. So the title of the work that we have done is producing an analytic dashboard for personalized e-learning, a preliminary study. Yeah. Right. So I'll be giving an introduction on just a brief scenario on e-learning, personalized learning, and how analytics comes in, why is learning analytics is important. I'll be showing some related works, a few developed dashboards out there, and followed by objectives. So we'll look at the design of the system and the implementation that we have done, and finally followed by results and discussion, and of course future work. Okay, just a brief introduction to e-learning. If you all are aware, e-learning has started as early as 1960s. At that time, there was a computer system known as Plato. Plato stands for Programmable Logic for Automatic Teacher Operation. Yeah. So what it does is that it allows teachers to access to curricular materials from a centralized hub. Yeah. So since that, we have many tools emerge in order to assist teachers and learners in terms of learning. Yeah. For example, in 1989, we have the World Wide Web. Where people can already start doing remote learning, and we have the first online school, yeah, in the US, which is known as Compute High. So that started in 1994. Yeah? The term e-learning was firstly used in 1999. Yeah, that was quite recent. It was coined in a conference where the participants were from relevant academic background. Since that, there have been many new terms emerged. For example, we have the MIT OpenCourseware, started in 2002, and then we have the MOOC. Yeah, so MOOC was quite recent, so it started in 2008. Yeah, so we know there are many advantages of using e-learning. For example, it is cost saving. It is flexible. You can study anywhere at any time. It is convenient. So if you can't travel, if you have limitations in traveling, so e-learning is good for you. And most important, that it supports personalized learning. So moving on into personalization. So we know that personalization is the 21st century buzzword. I'm sure if you have subscribed to any application or system, those applications or system provide some features for personalization. Yeah. So personalization started from the business domain, where business started to segmentalize their customers through CRM, the customer relationship management. So if you still remember at that time, we get some personal messages from the from any CRM division in any organization, started to give personal offers and so on. Yeah. Another example of personalization, I would use Netflix. So Netflix gives you movies recommendation based on your personal experience. It depends on what you like to watch. For me, I like to watch criminal movies. So every time when I log on into my account, it will give me the recommendation of movies related to criminal and law. From doesn't matter from the Hindi movies, Korean movies, or English movies. But recently, I love to watch, those from the Hindi movies, criminal and law. This is not the typical movie of singing, running around the tree, guling-guling kat bukit. No, this is the good Hindi movies now. So my recommendation of top 10, has most of them will, are from the Hindi movies. Yeah, yeah. So back to education. So there are many definitions of personalized e-learning. The one that I took from International Society for Technology in Education stated that learning that is tailored to the preferences, interests of various learners, as well as instruction that is based to a student's unique needs. While Bill and Melinda Gates Foundation stated that personalized learning has 4 key attributes, and there are learner profiles, personalized learning, personal learning path, competency-based progression, and flexible learning environment. So broadly speaking, I would say that personalized learning is to customize the learning experience for each student based on their abilities, based on their unique skill, based on their preferences, background, and also experiences. Yeah. I'm pretty sure that you have experience, because all of us came from the, having a, being taught in a physical classroom. Yeah, in a physical classroom, there is this connection between instructor and also students. Yeah, even if you have if you don't have the experience of becoming an instructor, you have the experience of being a student, right? So being a student, sometimes we tend to follow the class easily. Okay, so some students, they prefer to learn through materials like videos or images. So students nowadays, they just love using YouTube as their references. Okay, some students, they are very good in their psychomotor skills, but some students, they are not, so they prefer cognitive ability and so on. Yeah, so imagine if we have to do this to understand each of our students. Okay, what is their preference, whether they like to learn through video, or whether they like to learn through images or audio and so on, or whether they only want to focus on their psychomotor skills. It will be difficult or impossible for us to identify these requirements or preferences for each of these students. Yeah, so this is the scenario of one fits all that we should disregard ataupun tolak tepi nowadays. Yeah, because of we have been using technology for, I would say, almost 2 years already. We have been forced to do that. Yeah, all schools, universities, or even if you are if you're in a working environment, you do a lot of meetings and so on. So there are many data or information that can be captured through these technologies. Okay, so so this is where technologies help us, in order to capture all this information. We probably need to use multimodal medias. Yeah, for example, we need to use not just the VC, the video conferencing tools. Okay, we may have to use audios, images, okay, textual material, and we got all this information, and then identify the students' feedback, and from there we can use this information to customize our teaching for the next lesson and so on. Okay, so for each students, if that's possible. Yeah, yeah. So we know that by using the what we are using now is learning management system. Okay, I'm sure all universities use learning management system, whether they are public universities or private universities. In fact, schools, not all schools are using, but schools, the public schools are mostly using Google Classroom. Okay, so there are many data captured into this learning management system. Yeah, so this kind of system, what it can do is to identify which student come to class today. Okay, so based on the attendance, which participate in the online activities, okay, which have done the quiz within time, which have submitted the assignment within time, and so on. Yeah, so however, what this system providing is merely on reporting, not much of analytics, because it doesn't give us the whole scenario of what's going on. Yeah, so this is where analytics comes in, because it provides insights for each of the students, for what we can do to help the student. Yeah, so I'm pretty sure you have used, Moodle. I'm not sure about other university, but most of the public universities are using Moodle. So Moodle has its own analytic features, but not all instructors are using the features. One thing is because Moodle is not easy to access in terms of its not user friendliness. I would say that. Okay, so you have to go and dig for what kind of report that you want to search for. Yeah. So why is analytics important? Because the most important, I will have to go from this the lowest benefit here, the down part here, because it provides early intervention to retain students. So the reason why we have learning analytics is not just to identify the learning preferences for each of the students, but also to reduce the dropout of the students, and most important is to identify the students who are at risk. There have been many works for the dashboard, the learning analytic dashboard. The one that I mentioned just now was Moodle. I would say Moodle, to me, Moodle kind of not a user-friendly dashboard, but it still has its analytic features. But when you look at the analytic features, the graphs are boring and so on, yeah, because Moodle is not developed to be in terms of being an assistive technology. So so it's a kind of boring. So no wonder when we first introduced Moodle, so most of the senior staff they kind of reluctant. I think find it difficult kot to use Moodle ni. Yeah. So to me, Moodle merely provides reporting sahaja. Yeah. And then the Core Signal is one of the quite popular dashboard developed by Purdue University in the US. So it's using core signals, just like the traffic light system. So it has green color, yellow, and also red. So if the student is in the red zone, so the system will trigger some message to the student. So basically, this is for the interaction between academic advisors and also the students. Yeah. So next system is known as LISA. So LISA stands for Learning Dashboard for Insight and Support During Study Advice. So again, this is also a dashboard used by the instructors and the academic advisor and also students. Basically, it's for the advisor. This is just to ease communication between the instructors and the students by visualizing the students' mark lah. And we have Gradecraft. So Gradecraft is a good tool because it uses gameful courses to how do I say this, to strengthen the engagement of learning for the students. So it is fun. It also provides analytic features, to monitor the progress of the students. And finally, we have LADA. LADA stands for Learning Analytic Dashboard. It also uses the color of the traffic light system, green, yellow, and also red. It has a predictive feature where it allows the advisors to look at some possible scenarios before making any decision. Right. So although we have quite a number of analytic dashboard out there, but I believe that every educational institutions, they have they use different factors in order to monitor the progress of their students. Yeah, for example, in UPM, we identify students who are at risk by looking at the assess of their assessment, the first 7 weeks of their assessment. Yeah. So if they fail the assessment, so they are potentially to be on the lookout of being at risk system. And also if they have an attendance that is below 80%, so they are also they are also to be on the lookout lah for possible to be in the at-risk list, because students who do not fulfill the 80% of the attendance, they are barred from taking the final examination. Yeah. So based on the related studies that we have done, so we found limitation in terms that those systems do not allow students to self-evaluate and monitor performance among their peers. They're not able to monitor attendance status and their current CGPA. And there is no reminder on submission of assignment, no feedback on submitted assignment, and lack feature of final grade prediction. So we think that having this assignment, submission of assignment and feedback, they are important because if you come across a student who have difficulty in doing the assignment, so having this kind of reminder from the analytic system should help the student to get back on track. Yeah, inshallah. So our objective is to create a learning analytic dashboard to allow students to monitor their academic performance, attendance status, and assignment submission deadline, to allow students to predict their course, final score, to provide timely feedback for assignments, and to improve student retention by providing early warning using color visualization. So this will be the design of the dashboard. We name our dashboard as Dashlearn. So those are the features that this dashboard provides, is to view the CGPA attendance. There is an announcement tab to display assignment submission reminders, and the student can also view the current courses they are taking for that particular semester. So this is an overview of Dashlearn. So at the left side, so this will be the main menu. So we have the home page. This will be the home page. There's an assignment feedback page. This will be the list of courses currently taken by the students. So in the home page, we have the CGPA of the student. So we use color to indicate that he is in a good standing. Same goes as attendance. We use color to indicate that the student is in good standing. So if you look in this example, student here has attendance status less than 80%. So that's why we color the attendance status as red. However, for the blue one, the student is in good standing. So same goes for announcement. So we use red color to indicate that the student has passed the due date. For yellow color, the students have a few days left to submit the assignments. For the green color, the students have more days to submit the assignment. And then we have the course overview. Will display all the courses taken by the students. So each course is broken down into the assessment, the formative assessment. Yeah, but I think we need to fix the color here. It's quite difficult to identify test 1, test 2, Amali quiz, and so on. Yeah? Right. So we implement Dashlearn using libraries in Python. So we use Django for the web application development. For visualization, we use Bokeh to store the data of the students, courses, assignments, and so on. We use PostgreSQL, and we use integration of Pandas and sklearn to develop the predictive model. Pandas basically is just a 2D structure to to store the data. Yeah. So we use linear regression as it is commonly used predictive modeling technique. Linear regression is used to identify the significant relationship between the forecasted variables and the independent variables, assuming that you want to identify or predict if income influence your happiness in life. Yeah. So that's only one independent variable. Yeah. But you can have more, not just income. Yeah. Health is probably one. Yeah.
Dr. Masra, you have 2 minutes more.
Okay, thank you. Okay, so this will be the results, the overview of the course performance. I'll go deeper. This is the overall of the student performance in the course. Okay, so right here indicate the ranking of the students. And this is for the formative assessment for test 1 and test 2. The rate bar chart here indicates the ranking of the students compared to their peers. This is the assignment feedback where the student can view feedback from their instructor. And then we have the prediction for the course, the final grade. In this case will be the final score lah. Okay, of course the grade comes later with it. So the blue line represents 60% of the carry mark, while the 40% here comes from the predicted score for the final exam. So this will be over here will be the final marks, okay, achieved by the students based on the predicted marks. Yeah. So as a conclusion, Dashlearn has successfully been tested and has utilized learning activities and assessment data of students to visualize the students' performance and predict the course final score. Yeah, and well, of course, there are many things to do for this. There are still it's a long way ahead lah, to complete this task, because you can, you know, besides the features that I've mentioned just now, you can integrate other intelligent features. For example, you can have chatbot, okay, to help students, giving the reminder instead of the system trigger itself. So, having a chatbot nowadays is more user friendly and it's more interactive. Yeah, we hope to use more data for visualization and prediction, more courses, okay, more student involvement. Yeah. We tested only with a few students. We hope the system in the future can identify student learning preferences. We hope to integrate with the instructor component, because learning analytics will not be done successfully with without the instructor. And finally, we hope to integrate this with any current learning management system, because it contains all the data of assessment, the attendance and so on, for more comprehensive data and also for better insight. Thank you so much.
All right, so I think you are on the dot.
Thank you, Sarah. Thank you.
Okay.
Okay. Yes, any questions?
Can I ask?
Sure.
So with the prediction that you did you test it? I mean, did you compare with the actual results?
As I said, yeah, we did only a few. We did not get exactly the score, the exact score. Let's say 80 and 80, but we get within the range.
Ah. Okay. I think you're breaking. I don't know whether I'm breaking or but I think it's okay.
Okay.
I have a question.
Yes.
Is this system currently being used in UPM?
No, it's not. It's still in the development, because it's not completed yet. It's only a very small scale system. There are many things to do with the system. The most important is to do integration with the instructor component.
I see. Thank you.
Welcome.
I think it's a very nice system that you have there. So hopefully it will be, up and running.
Oh, yes. Thank you. Okay, if there are more systems, I'm back to changing my hat to being the session chair. I hope it's okay that we start with the next presentation. The next presenter will be, hold on, No Shakira.
Yes, I'm here.
Okay, would you like to continue presenting?
Okay, sure.
Thank you.
Can you see my screen? I'm changing to the presentation mode right now.
I think Dr.
not
Masra,
yet.
you are still.
Okay, sorry.
Yeah.
Oh, yeah, sorry. So sorry, Shakira. Okay, done.
All right. Okay, here's the presentation slide. Can you see in the presentation mode?
Yes.
Okay. Assalamualaikum, very good afternoon, everyone. My name is Nur Shakira binti Mat Saleh. On behalf of my team members, I would like to present our review papers entitled A Systematic Literature Review of Electricity Load Forecasting Using Long Short-Term Memory. This is the presentation outline. So we'll start with the systematic literature review, followed by the methodology that we implement using the SLR, and followed by the discussion, results and discussion, conclusion, acknowledgement, and references. Okay, we start with just refresh up the literature review. Okay, systematic literature review consists of 6 phases: scoping, where we want to formulate the research question by selecting the study area and also some sample case studies, because of course we cannot cover everything. And the next phase is the planning phase, where we have a list of keywords and we will find any synonym, singular or plural, or any different spelling, because as we all know, British English, the spelling is slightly different from the American English. So that may be contribute to our research finding or search paper finding. And then next phase is the searching phase, where we retrieve the articles from the relevant platforms such as IEEE Explore, Science Direct, MDPI, as well as Google Scholar. And the fourth phase is actually the screening process, where from the searching that we have made based on the keyword that we have selected, we will review the title and also the abstract of the article. And if, let's say, the title is considerable, yes, we can include in the citation manager. And usually we will use the EndNote Zotero. But recently I found a new online platform, which is the citethis4me.com. Okay, and then we go to eligibility phase, where we will review the full text and we will keep track which one important that is that should be included in the research, and then we decide whether the research method type, whether it is a quantitative or qualitative research. Okay, basically, in the scoping phase, we are focusing on the electricity consumer, because as we all know, electricity is very important to all of us. If we have no electricity, then it's impossible to have even this online conference. So it's important for the residential household, it's important for the commercial as well as the factory. Okay, but when we want to use more electricity to fulfill our daily routines or daily running our daily life and so on, when we demand more electricity, means the electricity power company need to generate more electricity. So how much electricity need to be generated? If, let's say, in a what we call it conventional way of generating electricity, they use the non-renewable energy such as coal. So when we want to generate electricity using coal, for example, indirectly it will increase the carbon emission. So due to that, if you heard about the renewable energy or green energy, so the renewable energy actually generate the electricity from the renewable sources such as wind and also solar panel. But however, the limitation in using this renewable energy is about finance resources as well as the expertise to maintain it. So not all country are already in the renewable energy phase, including Malaysia. Malaysia is still using the conventional way, where we use coal to generate the electricity as well as the hydro electricity. So we cannot extremely convert from the non-renewable to renewable energy, but the least that we can do is to generate electricity according to the demand by applying the short-term prediction, so that we will generate electricity to meet the users or the consumers' need, but not to overproducing the electricity. So to do this kind of short-term prediction, we implement in time series. I believe for the keynote speakers for the yesterday and also this morning, talking about the regression, talking about time series. So yes, recurrent neural network (RNN) is one of the example of time series, but RNN has been improvised by long short-term memory (LSTM) by having the more memory cells, so that whenever the iteration happens in the learning process, it will still hold some of the weight in each of the cycle. So we start with the methodology. We start with the planning phase in searching the potential article for our research. So here are the list of the keywords that we have used. Okay, and then we identified the synonym or acronym, and we also identified is there any different spelling or single or plural form of representing each of this keyword. So from the keyword that we have gathered, we identified 8 combinations, or we came out with 8 combinations of the keyword that we will use this in our search later. So in the searching phase, we search on the IEEE Explore database that covers years from 2019 until 2021, because we want to know what's the latest thing about electricity in short-term electricity that produced by other researchers. So from this combination, we managed to gather in total of, or we managed to found 368 articles, 280 is from conference paper and 71 is from journal. And not to forget, the total early access article is 17. So after we search, now it's time to screen, where the most important part is we will review the title and abstract, and we will carefully inspect, because this is critical. This is where we will remove some of the non-necessary or non-related article. So all of the what we call it article that we found, we screen over here, will be stored or will be recorded in the site thisforme.com. This is similar like Zotero and also EndNote, but in this case we use this site thisforme.com. So for this one, in total, we managed to from the screening process, the final articles from the screening was 25 articles. 22 from conference paper and 3 from journals. So here comes the eligibility phase, whereby from the what we call it screening phase here, we will carefully evaluate by reading the full text of the article, and we will carefully inspect which one is important or not, which one is in our scope or not. So from there, we managed to get 11 total eligible article that totally come from the combination number 6. Okay, just now I mentioned about the research method that we will implement. So in this case, since we are dealing with statistical data, we are going to implement the quantitative research synthesis, whereby we will implement the supervised learning, which we will allow the machine to learn from samples. And then the selected algorithm is as LSTM. And from the data set that we use as a sample, we will train the machine, and the output of the training process is actually a model. So we will evaluate the model using the evaluation metric, and then we will perform prediction using the model that we have generated. So for the statistical data that we are going to include in the training process, that is actually consists of the historical load data, which is include the date, time, and usage, as well as independent variables that includes weather, temperature, date type, and also holiday. So for the record interval also plays important roles in conducting research. Some of the researcher may include the the time interval for every minute, 30 minutes, 1 hour, and 1 day, because if you use the conventional meter, we will only get the record for 1 month, because we will get our bill for every month. But due to the invention of smart meter, now we can get the records for as short as every minute. And for the training and testing ratio, usually it comes in 70-30, 80-20, and 90-10. And as well for the evaluation metric that being used in RNN or LSTM, these are the 5 evaluation metrics that usually being used in this algorithm. So for the results and discussion for the 11th article found in the eligibility phase, okay, just to recap, the publication duration was from 2019 until 2021. So, okay, these are the articles. These are the 11 articles that we have gathered from 2021 until 2019. So from 2019, we managed to get 2 articles related to this area. And then 2021, we managed to get 1. And for 2020, we managed to get 9. But I believe this paper was written in May. But now, since we have so many conferences happen recently, of course, the number of articles for 2021 will be increased. So let's focus on the dataset first. As we can see over here, the historical dataset. Okay, the left side here is for the reference. So yeah, these are the list of dataset being used by other researchers, other papers, and as we can see, each paper use different datasets. And some of the scope consumer, it covers the city, one household, or one commercial building, or even one country. And the duration also are slightly different. We will see the summary in the next table. Same goes to the data interval, and we also managed to extract the training and testing set duration that being used by these researchers. So as you can see in this table about the occurrences, how many researcher or how many articles implemented 1 minute data interval, which is only one articles that we found. But the most data interval that we found from the articles is the researcher used 1 hour, which is 5 articles was found that use 1 hour duration. And for the consumer, yeah, it's more or less the same, but exactly same for city and country. Okay, many researchers do the prediction for the whole city as well as for the whole country. And for the dataset duration, most of the researchers use between 2 to 5 years of dataset duration, which that occurs in 6 papers. And then for the list of features, okay, as I mentioned in the previously, okay, the sample of electricity usage or the sample of the historical data consists of electricity usage. But some other researchers put more effort in including the independent variables because they stated that independent variables may influence the consumer behavior. So to show that the work that has been done by other researchers, there are 2 researchers was implemented the independent variables in their article. So they have included temperature, holiday, special day replacement, and also climate. And as well as the researcher for the reference 16 here, which is they included the weather and also a special day as the independent variables. And for the evaluation metric, as we can see, various different researchers use different evaluation metric, but we will see the summary of it later. And as for the result, we can see there are various range of results, some between 0 to 1, some get even hundreds or 400s like this. So from our analysis, we found that probably the cause of this different range because of the data use was not scaled. Okay, so because we are dealing with different range of data and it's not scaled between 0 to 1, that's why we get this different range of result of the evaluation metrics. So, I didn't include the table to summarize the evaluation metrics, sorry. But yeah, in the paper, there was a summary of how many papers that use MAE, MAP, and also RMSE. Okay, the conclusion here is what's the actually outcome of this paper? We identified that, of course, historical load data has been used as the main data source to do the prediction. But however, more effort can be done to increase the model accuracy by adding independent variables such as weather to help to reduce the model error, which means it will increase the model accuracy. And after that, the data set duration commonly between 2 and 5 years. But it depends on the data set duration and it depends on the data interval. Yes, 2 to 5 years is commonly being used, but maybe we can also add more independent variables to help to overcome if there are any data, what we call it, data shortage or what. And then for the training samples, we can conclude that training sample should at least 60% from the overall data set, which means you train more than you test. And the test data set should not be included in the training samples to avoid any bias. And finally, we found that the common evaluation metric used in regression method was RMSE and MAPE. And we would like to thank to URND TNB Seeding Fund for sponsoring this paper, as well as IICE and Southern Denmark University for the collaboration in providing the data set as well as helping with the R&D. So here are the references that being used in this paper. So thank you.
Thank you, Shakira. We have a few minutes left. Any question? Boleh tanya soalan ni? Any questions from the floor? Shakira,
Yes.
I have a question. In this situation right now, how can we make electricity more affordable?
Oh,
Yeah.
that we need to ask the NB.
So based on your work, because you're doing prediction for load factoring, right?
Yes.
For electricity, what is your opinion about? Because yes, we know that Malaysia is not in its full capacity of using renewable energy lah, kan? I think lambat lagi for that. You're still using hydrogen and coal, as you mentioned just now. But how are we? I would say that our status now, since like I'll just go to the point of using green hydrogen. Are we into that too? At least having green hydrogen to replace hydrogen itself.
That one I haven't came across any articles for bringing that, because now it's very I mean, yeah, with the current situation COVID right now, I think everyone are trying to be more sustainable, right? So the latest approach that I came across was actually to by TNB introducing the smart meter to be implemented, because the purpose of the smart meter, actually they want to allow the consumer to monitor directly on their usage. It's similar like when let's say we since we can monitor the electricity usage in hourly, for example, we can estimate, oh, if let's say it's only the first week of the month, so I already use like 50 ringgit, so the next days I should control my electricity usage, or just to give the awareness at the first place first. So that's actually the intention of smart meter, actually to self-educate the consumer, so that they are aware the number of electricity, the amount of unit and the price that they are currently using, and they can control themselves in using the electricity in the next few days until you reach for the billing date.
Cycle, yeah, billing date.
Yes.
Okay,
Yes,
yeah,
I
that's a good effort. At least it keeps keep us alert, okay?
Yes,
And our
yes.
sekarang ni dia kan duduk rumah 24 hours,
Exactly.
like air condition 24 hours, so it's kind of dangerous if you don't have that alert system. Yeah, we may not realize that we have go beyond what we should not lah, kan?
Exactly,
Okay.
because me myself also experience the ups and down in using the electricity bill. We only know our bill at the end of the month, and sometimes the bill is low, but the next month it's become high because probably I use more aircon, and also I
Yes.
use more oven, not including all the new kitchen or fancy kitchen that use electricity. So I think the main purpose of smart meter is actually can really helps in for the consumer actually to self-realize that yes, we need to monitor so that we need to use the smart meter so that we can monitor and we can control ourselves in using the electricity, which I think is fair for the consumer itself.
Yeah. Okay. Thank you, Nur
Okay.
Shakira. Any more from the members?
Yeah, I think no more because this is just a
So,
review paper.
yeah, but since you have read so many things, so probably you have some ideas,
Yes, yes, yes.
on your perspective, you don't mean. Okay, thank you very much
Okay, thank
again,
you.
Nur Shakira. So we move on to the next presenter, TS Dr. Rahani. So Dr. Rahani is my colleague from UPM. Okay, the floor is yours, yeah, Dr. Rahani. Rahani, okay.
All right, thank you, Dr. Chairman. All right, let me share my screen now. Okay. Sorry. All right. Assalamualaikum and a very good afternoon, everyone. My name is Raihani Muhammad. So today I will present to you regarding our work entitled Adaptive Profiling Model for Multiple Residence Activity Recognition Analysis using Spatial Temporal Information in Smart Home. So basically this is the the work collaborated with the Muhammad Narazlan Shah Zainuddin from UTM and the other two from UPM, Dr. Tinagaran Perumal and also Dr. Sufi Muhammad. All right, so basically the presentation today will be covering the introduction, problem statement, the proposed work, the methodology. Yeah, the methodology I will brief regarding the data set, pre-processing stage, and also the adaptive profiling model. So the adaptive profiling model will be covering the spatial information, temporal information, and also adaptive cluster size. Right after that, we will go on experimental design, result and discussion, conclusion, and also the future work. All right. So introduction, we will start with introduction. So basically, today's or previous work more on recognize the activities by single resident. All right, meaning that only one resident is classified and recognize the activity of the single resident in the smart home environment. But anyway, in today's pandemic, we face everyone and everyone need to work at home and do activities at home. So there is a need to have the accurate model recognition of multiple residents activity that reside in the smart home environment. Okay, so when there's more than one resident reside in the same environment, so basically the ADL types also might become complex. So ADL type here is the activities daily living, such as cooking, eating, toileting, and also maybe dressing and so on, is the ADL types by the human in the smart environment. Okay, so the ADL type might become complex when it was dealing with multiple residents that reside together in the same smart home. All right, so and as we know, smart home also is was embedded with an ambient-based sensor. All right, so it was harder to recognize the ADL accurately. So the sensor like motion sensor, item sensor, what else? The door sensor, all installed, and human interact with the sensor seamlessly. All right. So other than that, due to privacy and security concern, also people were reluctant to install CCTV at their environment. So By that, tracking the activities performed is also hard to identify in a smart home that has been installed and embedded with an ambient-based sensor. All right. So other than that, maybe we have another type of a sensor like wearable sensor. Okay, but unfortunately, when we deal with elderly people, so basically they are reluctant to wear it because they feel that that one is susah to bring together when they're doing the activities. All right. So due to that, in this work, this research actually look how much the spatial and temporal information and features of the census pattern that will be affected model trained with adaptively recognized ADL. All right. So next is regarding the problem statement. So basically, the additional information from the domain knowledge in a smart home environment is essential to model the activity accurately. Generally, the context information actually is used to describe the situation of the person in a particular environment because before the study from day and abroad, define the context is typically the location, identity, and state of people, also groups and computational as well as physical object. Right? In a more specific way, the context information needs to be analyzed in order to provide meaningful information. So from Cook et al., 2010, they say that inadequate accuracy also occur when the sensor events are overlapping, since the dataset contains is a combination of individual, parallel, and also cooperative type of activities. All right, so basically in a smart home environment or that reside by more than one resident, there are also the activities, there are also interactive activities can be occurred. All right. So the individual activities here is referred to only one person is actively doing the activities and the other person may be idle. All right. That one is categorized under individual activity. The parallel activity is basically defined as when two persons is doing the activity at the same time, but the activity is different in the different location. However, the cooperative activity can be defined as both the resident, maybe both or more than two residents, work together doing the same activity in the same location, right? That can be defined for the interactive activities in that sense. Okay, so the several investigation has been done using data mining techniques in semi-supervised learning algorithm with the integration of temporal features and parameters, where there were more studies that proposed 4 and also 6 room level specific region, whereby in a smart home, we call the region, whereby we know that in our home, there is a dining room, there is a kitchen, there is living room, there is what else? All that one is divided and we address it as a region in smart home. To create, so this region actually, they propose to create new features based on the motion sensors at the pre-processing stage. Okay, so however, the approach cannot cater the class overlapping problem when the model receiving the real world data set. Okay, so the class overlapping here can be occurred due to, yes, we know, as I mentioned, as I give you the scenario just now, if there are more than if two residents doing the same activity or different activity at the same time, basically the time series features of the sensor is keeping triggering, right? So because of that kind of condition happen, so the class overlapping problem occurred, right? Okay, so this is the proposed work. So basically this research will look into how much the spatial and temporal information as features of the census pattern, and it will be effective model trained with adaptive recognized ADL, right? So this model we propose to the smart home domain. So basically, the proposed model contains desirable features augmentation, such as adaptively previous activity information, with the possible number cluster based on the active label sets, because we know that in sometimes certain condition or certain activities can be done parallelly and also cooperatively. Okay, so we propose the adaptive profiling model to investigate the multiple resident activity recognition, all right? Okay, so next is regarding the methodology. So we selected the data set from the ADL-MR, Activities Daily Living Multi-Resident from WSU Casas. All right, so basically this data set represent the interactive ADL of multiple resident in the smart home environment. Okay, so as you can see, the table that I provide here, actually it is from the 16 types of ADL. All right, so basically this data set reported in the work from Sinclair et al. And then when we try to reconcile tally back with the actual data set, actually there's discrepancy. All right. For example, at Singla reported that the activity of B is for the resident, because the dataset is for two residents, A and B. All right, so B4, actually when we go back to the actual dataset, but actually it is annotated as A4. All right. Same like B6. B6 is for sweeping floor, but we realized that in the real data set, it is A6. That one is some example that, but the other one is like A14, actually done by B14, and B5 actually, A5 actually done by the resident B, just like that, okay? But from this one, sila. Okay, this one, actually, I want to put the arrow at the A13, yeah, A13 and B13. I don't know why the arrow is go to other column. Okay, but anyway, what I want to show here is A13 and B13 actually the cooperative activity, because resident A doing the activity retrieving dishes from cabinet, and same as resident B, okay, retrieving dishes from cabinet. So from this data set, actually there's type of individual activity, also parallel activity, and also cooperative activity. Okay, so but for this experiment, okay, using this data set, we will continue with the actual data set, not by the reported by the Singla. Okay, so we proceed with the pre-processing stage. So in order to process the sensor signal in the time series, so basically what we did is we extract the feature from the sensor triggering and also do the cleaning. So this process actually I reported in my previous work. Okay. So what we want to show is how the feature augmentation would derive from the spatial temporal information to have the adaptive profiling for the multi-resident in the smart home. Okay, all right. So this is how the adaptive profiling model that we propose actually look like. All right. So this is the overview of the proposed method. Okay, so basically we can start that we have the MBMB sensor, and then we also derive the features from the temporal and also from the spatial, if you can see here. And then we combine both with the MBMB sensor as well, and then cluster using the EM, expectation maximization clustering, and then to have the adaptive profiling for the multi-resident. Okay, so how do we get the temporal information here? Is basically by looking at the previous activity of that particular resident. Okay, by logic, actually when we did something, actually before we do something, of course it was previously we did already the activity. Okay, for example, before you go to the before you proceed with sleeping, of course, previously maybe you do the toileting. All right, so basically this one is actually becoming the pattern of the activity of a person. All right, so we consider that as a temporal information with the pattern of how the activity is done by particular person. All right, so the other one is the feature from the spatial. So basically, how do we get the spatial here? It actually from the location or the region in the smart home itself, right? That reside by our multi-resident. All right. So basically, we segment the region, and after that we scan the region with some weight here. Okay. All right. So how do we get the weight? Basically, we divided. Okay. Okay. So let me explain to you about the Casa smart home layout. Okay, actually they give us like this, but we just cover to this level. All right, so this level, so basically we annotated or identified the region with the R1, R2, R3, R4, 5, and 6. All right, maybe there is a living room, dining room, toilet, and so on. All right, so from the region, we retrieve it into this, we identify it based on the sensor location that it was being installed. Right, for example, for the region 1, okay, let's see this region 1, it covering with the 1, 2, 3, 4, 5, 6 sensors that are located in the region 1. And then we put it some weight, that possibility of that sensor can be triggered as 1 when there's motion or the interaction from the human make the sensor triggered. All right, so this is how we retrieve the weight for the spatial region scan. When there's movement, or there's activity, and the sensor is triggered, and then actually the sensor triggered with some weight. Okay, all right. So next is adaptive cluster. Okay, when we identify this spatial temporal information, and also combine with the MBMD sensor, all right, so we proceed with the cluster process using the expectation maximization. Okay, so we generate, in order to generate for the clustering, of course, we need to know how many cluster sizes to put in. All right, so for this work, actually the parameters of clusters are adaptively defined from the data sets, yeah, based on the number of active combined label set of the training data set. So the cluster size here is from the data set that have the combined the active combined label set. That one is considered the cluster size for the our clustering, right? So next, about the experimental design. The proposed adaptive profiling model was classified using multi-level classification technique, okay, namely label combination method that combined with many base classifiers, right, such as random forest, ScanN, SVM, and HMM. So basically, we use the multi-level
Sorry, Dr. Rohaini, sorry to interrupt. You have 2 minutes left, yeah? Thank you.
Okay. All right, I try to move forward faster. All right, so basically we do this method LC combined with the single label classification near random forest, ScanN, and also SVM. So yes, we did 2 experiments. First experiment is running without the the proposed model. The second one is running with the proposed model. All right, so this is the training, how we design the training. All right, and then this is the result and discussion. So basically, this is the first result from our first experiment. All right, so basically from this model and classification, this is the accuracy per level of multiple resident. So basically, we know that the activity done by that particular resident get this accuracy. So with the to be short, the combination of multi-level classification with the RF random forest basically got the highest result, 0.947. All right, by that we also using this method also can actually recognize the cooperative activity, what type of cooperative activity that done by that particular person. All right, so okay, so basically the model performance, actually this is the additional one. When we use the multi-level classification, basically we need to also test in terms of example-based model performance and also level-based performance, right? So when we test using the second with the proposed method, basically the Hamming score of each of the activities by the resident is increased up to 0.998. We also compare with other classifier, KNN, SVM, and also HMM, but we see that 0.99 is achieved by random forest. Okay, so other than that, also compare here. All right, and then this is based on the result. So basically, what we get, what I want to show here is that the basic features, the comparison of the basic features using the multi-level classification using the only MBMB sensor. So actually, in the gray one and the yellow one is using the proposed model. All right, so you can see that the model increase, right, when we add with more features. Okay, we also compare the model performance with the previous work, Cheng and Tong. All right, they use the single level classification, HMM method, and CRF, and other work also using this new recurrent neural network. But this Tran et al. Only can recognize the activities interactive that I mentioned, like the parallel and cooperative. They just label it as combined activities. Yeah, but the accuracy is 0.878. All right. So hence our study proved that the combined dataset can be recognized in types of activity and the performance as well. So actually the adaptive profiling model result accuracy is with 0.986 Hamming score, and the accuracy of 0.986, and the Hamming score is 0.998. Okay. All right. So as conclusion, all right, and the future work. In the future, we will investigate on the interaction type of activities. Yeah, we want to know the activities that, for example, A13 and B13, is it the cooperative and parallel? Okay, so the work can be done in future. All right, and then the second one is the model also needs to be ready with the incremental number of residents that reside together in the smart home and in the same environment. Okay, so that's all. Thank you. Any question?
Thank you, Dr. Raihani. Dr. Raihani, any questions from the members? Very interesting work, Dr. Raihani. I would like to ask, if you have, activities, overlapping activities by these multiple residents, do you consider those activities as, those overlapping activities as noise, or do you still take that into consideration?
Yes, we take that into consideration, and we try to study the pattern and identify what kind of activity that done when there's a noise or overlapping of the sensors happen.
Okay. So the data set that you shown just now, are those data, they came from live sensor or from the database?
This one is from the public data set.
Public data set.
Yes, actually they already use this one in the WSC Casas.
Okay. So are these data sets validated, meaning that, when they have obtained the results based on the activities from the multiple residents in any home? So do they validate, is that the activity in a real residence home? Has anyone done that part of research? Whether they are aligned?
That one they tried some of the cook, because this one is from the cook, the Diane J. Cook. Actually, they already tried to transform the model into the real world. They found that it's a little hard to recognize unless they plan for the activity.
Okay, but so there has been an attempt to do that lah. Okay, all right. Any question? Ada soalan from the floor? Kalau tak ada, we can end the session for Dr. Rahaini and we move to the next speaker. Thank you again, Dr. Rahaini.
Okay, welcome.
Ms. Yvonne.
Hi.
Yeah.
Shall I share my screen?
Yes. Right, I forgot to introduce the title for all the speakers I know. Sorry, because I was having difficulty with my notebook, so changing notebook and so on. Yeah. So yeah, Ms. Yvonne will be presenting her work on memorability of legacy password types in gaze-based authentication. Yeah.
Okay. Can I check whether you can see my screen?
Can, very clear. Go ahead.
All right. So I'm going to present. Memorability of legacy password.
It's stopped. Is anyone has a problem or just me? Okay.
Just a minute, because I'm playing a video.
Okay.
Try again. Memorability of legacy password types in gaze-based authentication. Motivation. Gaze-based control can facilitate
Sorry, I heard an echo.
touchless and also touchless interaction, which are especially important during the COVID-19 era. One of the applications of gaze-based control is actually gaze-based authentication, which has the advantage of being able to resist shoulder surfing during login, because the interaction from the eyes is not easily observable or not observable on the screen. Under this kind of authentication, there are several password types. One is the legacy password types, which include text like passwords and pins, and also pictures as passwords, and these are compatible with the existing server backends. The other kind of passwords are actually eye gestures, for example, movements of your eyes, which are detectable by the tracker and the computer, but these are not compatible with the existing server backends. So in this research, we want to study a picture superiority effect. So this effect is something that's been researched and well known, where research shows that semantically dissimilar pictures were more memorable than pin numbers. So semantically dissimilar means that the pictures are very distinct, meaningful, and they are different from one another. And they are found to be more memorable than text, such as pin. But how about if the pictures are similar? Will the similar effect be seen? So in order to do this, we implemented and tested two methods of authentication, which is the pin-based and the picture password-based authentication. And we evaluated these through user testing. Now we go through a literature review. In this paper, there was a study on a graphical password on the computer. So this is a study without using the gaze authentication, but just normal mouse authentication using the mouse. And in this research, they studied the implementation of this graphical password called VIP and compared it with the PIN. So the pictures that were chosen were from different categories, one picture from one category. And so they were actually semantically dissimilar. As you can see, there are pictures of flowers and animals and minerals, and all of them come from different categories. And so we see this as an example of semantically dissimilar pictures being compared to pins. The researchers found a picture of superiority effect, surprisingly, was not replicated at the first outset. Meaning that when they use this in comparison with the pins, means one picture correspond to one pin. So it was a pictorial equivalent of a pin. At the first outset, on the first attempt, they did not find a picture superiority effect where people remembered these pictures better than the pins that they authenticated with. However, it was seen in later attempts in the following weeks and months where people remembered these pictures better than the pins. Over here is a survey of the existing eye gaze applications. So in this, we see that there is an uptrend in the eye gaze applications, especially in terms of authentication. Next are just a sequence of past authentications using gaze-based control. So I'm just going to show a selection of image-based and also text-based and also gesture-based. So these are the image-based ones based on a grid, based on the semantically dissimilar pictures, based on, again, semantically dissimilar pictures, but based on clicking on regions or basically gazing on regions to authenticate in several rounds. So one picture per round and one spot in one picture at each round. And these were concerned with hiding hotspots in the picture so that you can choose your password from the hotspots. And these are a series of text-based eye gaze authentication where you choose text. The password type is text. So this is a replication of the PIN at the ATM using eye gaze. Again, this is PIN, and this is also text, and this is a multimodal, which includes both PIN and also touch during PIN and during the entry. This one is the example of eye gesture, where these are the gestures that are available to be chosen as the password. So we summarize by listing the types of password that have been used in the previous literatures that were reviewed. And we see that there are also a number which are using the legacy password types. I've concentrated more on these because this is the focus of the research. And so we want to implement a PIN-based method, much like the ATM version, with a standard PIN password. And also we wanted to implement an image version, for a picture password, but with semantically similar images. Experiment setup. The eye tracker used in this project was the Tobii IX, which is shown here. So it's positioned at the bottom of the screen. And you can see here the software included allows you to calibrate to the user's eyes before usage. So this eye tracker is a commercial product and it allows and detects the user's gaze point on the screen with this following spec. So this was our implementation. We can see that registration part, you can actually choose your PIN and also your sequence of picture passwords, where each of the rounds, there are 6 rounds here, you should choose from a different category of pictures. So the categories that are given, you have 9 choices, which are these, like beach, building, bus, and flower, and so on. So each category contains pictures that have a similar meaning and visual similarity. The aim is to resist shoulder surfing by making it hard for the shoulder surfer to differentiate and remember the pictures, because each picture comes from a category, and later on the distractors will also come from the same category, so that they are semantically similar. So this is the authentication interface. So there's just a normal PIN, whereas this is for the picture password, where this is for one of the rounds where the category was beach. So the user has to pick out their password from among other distractors which are also having the same meaning of beach. Okay, so this is a procedure. PIN authentication is very familiar. They just choose their PIN. And for the picture password, the users need to make their selection from the group of pictures in the category. They need to trigger the space bar while looking at a particular picture, and they're given a maximum of 3 attempts to enter the password. These are the results. We had 27 participants, and in the PIN entry variant, all participants managed to enter their password on their first try. So it's very familiar to them, and they had no problem. And the mean time taken was 21.1 seconds. For the picture password, they were also able to enter their password within 3 attempts. However, they did not all manage to enter correctly on the first attempt. Only 66.7% were able to enter on the first attempt, while 33% were able to enter on the second attempt. The average time taken to enter their password on terms of successful attempts was 32.85 seconds. There was also a survey being done on the participants, and one of the questions was asked, which was whether they can remember their password easily, the picture password easily, okay, in contrast to PIN. And the most chosen option was actually they disagreed with the statement that they could remember easily. And we see the percentage of people who chose the lower 2 options, means strongly and also disagree. These would form 44% of all the participants, okay? With only 8 people choosing neutral and 7 people choosing agree. Conclusion. 2 methods have been implemented for comparison in gaze-based authentication in this research. The first one is the PIN number keypad layout. And the second one is a picture-based login using semantically similar images. So the purpose of doing this is to test the picture superiority effect comparing these 2, text and also semantically similar images. Based on user testing, both methods achieve a 100% success rate of login. However, PIN had a better login accuracy on the first attempt, where 100% of the participants managed to log in correctly on the first try out of 3. Whereas for the picture-based login, only 66% managed to log in on the first try, while 33% log in on the second try. So this may point to that semantically similar images having a poorer memorability because of this lower accuracy. This is also supported by the survey results, where 44% of the participants disagreed that they could remember their picture password easily. In conclusion, given the fact that gaze-based mechanism already resists shoulder surfing, it may be good to have dissimilar pictures so that we may provide a better usability without adversely affecting shoulder surfing resistance. Thank you. and I welcome your questions.
Thank you, Miss Yvonne. Any questions from the floor? Very interesting work.
Thank you.
We are actually ahead of time. So yeah, anyone who wish to ask questions, please go ahead. Miss Yvonne, I would like to ask, why didn't you have the experiment on having dissimilar pictures?
Oh, okay. Thank you for your question. I guess it was established in the previous work by other researchers. They compared between dissimilar pictures with pins. So they actually had a result. So we thought of doing something slightly different. But I think it would have added to the result also, I guess, if we had that third comparison. So it's a three-way comparison. Yes.
Okay. What would be the age of your respondents in this experiment?
They would actually be quite young people because my student did this and I think the respondents were between 22 and 23 years old. His batchmates probably. Yeah.
Okay. So if the young people having difficulty using similar image for their passport, I'm pretty sure people like me who's going into the 5 series also will have more difficulty. But anyway, this is very good because especially for the elderly lah, like me also going to be the elderly. I would have almost I think I have only 2 or 3 pins used in more than 2 or 3 accounts, which is not good in this case. Very dangerous, right? Okay.
Yes,
So
yes.
probably having pictures would help a lot. Yeah. But then you also, when you want to do this, you also have to look the retain of the memory because so say I have different pictures, right? So how good am I in recognizing that this picture is for this account, this picture is for that account, and so on. So how long can my memory retain those image also, which needs to be considered as well. Especially you can try with the elderly people, how this image thing works with them.
Yes,
And also
definitely.
probably people with having, what do I say this, people who are colorblind, having problem with their eyesight. So how would your study affect this type of people? So very interesting.
Yeah, there are many angles that can be studied.
Hmm.
Agree, that there are quite many angles that can be studied. And what you mentioned just now, the phenomenon of memory interference when you have
That's me.
especially when it comes to pictures. Yes.
Yeah. Okay. Sometimes you see that, hey, I've seen this picture. Okay, this is for this, and that, so it can be confusing. Yeah.
Sure.
Memory interference.
Yeah.
Okay. Any questions from the floor? Okay, if there are no.
Sorry,
Yes,
I have a question. Sorry.
Go ahead.
Yvonne, I just want to recall, did you include any machine learning elements in your study so far?
No, I have not included machine learning.
Okay. So it's purely processing the, understanding the gaze only and not really on the prediction, right?
No, not on the prediction. We use an eye tracker to capture the gaze data where they are looking at a particular time.
Okay.
Yeah, but yeah, this eye tracking actually has a lot of applications for prediction as well, but we didn't do that.
All right. Okay. Thank you.
Thank you. Okay. Yes, maybe we can proceed to the next speaker. Thank you, Yvonne. So the next speaker will be Wanor Fadlina Shamimi from Unimap, and her title of presentation will be Classification of Order in the Leftover Cooked Food in Determining Contamination Using Machine Learning. Okay, so this is also a good topic. Yes, go ahead, Wan. Sorry, Wan, have you started presenting because I can't hear anything?
All right, okay. Is my voice now clear?
Okay, yes.
All right, okay. Um, okay. Assalamualaikum and good evening to the chairperson, Dr. Masra. So, my name is Wanur Fadlina Syami binti Wan Azman, and I am a master student at UNIMAP. So, I will present my paper today, which is classification of odor in the leftover cooked food to determine contamination using machine learning. So this is actually my master project, which is supervised by my lecturer, which is Dr. Kunur Fazira Koazir and Dr. Miza Ameh. And we are from Advanced Computing Engineering at COM, Center of Excellence, Faculty of Electronic Engineering, University Malaysia Perlis, UNIMAP. And so my presentation today will be consist of introduction, materials and methods, results and discussion, and will be ended with a conclusion. So this is a brief, short introduction from my study, which is concerning on food waste. So globally, roughly 1/3 of all food produced for human consumption is lost or squandered, and this loss can happen during preparation, processing, and manufacturing phases in the food supply chain. And there were numerous evidence suggesting that the household sector is the significant factor contributing to the formation of food waste. So in Malaysia, the household sector accounts for 44.5% of overall solid waste collection figures, which is equivalent to 6.1 million tons per year, and with only food waste accounting 50% of total waste consumption. The literature reviews provided works done on the integration of an electronic nose, e-nose, and machine learning modeling to predict numerous different foods or drinks characteristics. However, there are no prior studies have been done to examine the contamination in the leftover cooked food using this method. So my aim, or the general aim of this study, is to identify and classify the level of the contamination in the leftover cooked food with machine learning through the order of the foods using the electronic e-nose. So this is the general proposed framework block diagram. So there will be two units interconnected with each other, which is the sensing unit and the classifier unit. So at the sensing unit is where the odor from the food sample is detected by the electronic sensors array and will be pre-processed. And at the classification unit, the pre-processed data will be classified. So at the classification unit is where the data will be trained and will be predicted also. So for the food sample preparation, the food samples that we use can commonly found in a Malaysian household, which are dalca sayur, nasi goreng daging, sup daging or beef soup, ayam masak lemak, ayam masak kunyit, ayam goreng merempah, and sawi masak air. And the experiment ran for 5 days in a row, starting from 8:30 a.m. and ends at 5:30 p.m. daily. And this food sample is placed in a clean airtight plastic container with sensors attached to the lid. So during the experiment, the container lid will be opened after every 15 minutes to let the sensor cleaning process takes place. So this is a general block diagram of the experimental setup. So as you can see, the study used four gas sensors, which are MQ2, MQ136, MQ137, and MQ138. And when the the sensors were used to detect the gases from the food sample, both when the food is still fresh and when it is spoiled. And then for the microcontroller, it will process the data from the sensor and then it is converted into the digital signal using the data acquisition tool. And after that, lastly, the data that has been converted into the digital signal will be stored in the PC. So in the PC is where the data analysis method happen using the Art Studio. So for the data analysis method, so we have here two parts actually. The first is using the machine learning, which were LDA, linear discriminant analysis, k-nearest neighbor, KNN, support vector machines, SVM, and RF, random forest. And due to the unbalanced data sets actually, we use four techniques to balance the data sets, which are oversampling method, undersampling method, random oversampling examples, ROS, and synthetic minority oversampling technique, SMOT. For the results, So the dataset contained 300 rows of values and 16 variables. The datasets were partitioned using the 80-20 ratio, where 80% of the datasets were training sets and the remaining 20% were test sets. So careful cross-validation was applied to the datasets, whereby the value of K is 10. The categories for classification was determined by observation during the 5 days of experiment. And the categories that used as reference group for the binary classification were fresh and spot. So the fresh were determined on most of the food samples that were fresh on the day 1 of the experiment. However, starting from the day 2 until the day 5, the food samples started to show signs of spoilage. So we go to the first classification result, which is using the LDA. So by using the LDA, the highest accuracy obtained was 78.57% by the food sample dacha sayur, ayam goreng berempah, and ayam masak lemak. And the lowest accuracy achieved was 53.57% by ayam masak lemak kunyit. And this accuracy achieved during when the data was unbalanced. So when the data was balanced using the oversampling method, sup daging and ayam masak lemak gave the highest accuracy, which was 55.36%. Meanwhile, ayam goreng berempah and dacha sayur achieved the lowest accuracy, which was 37.5%. So when the data was balanced using the undersampling method, the highest accuracy obtained was by sayur masak air, which was 57.14%, whereas the lowest accuracy achieved was 35.71% by ayam goreng berempah. So when the data was balanced using the ROS method, the highest accuracy achieved was 60.71% by the food sample ayam masak kunyit, whereas the lowest accuracy achieved was 42.86% by the food sample sawi masak air. For the SMOT technique, the highest accuracy achieved was 67.86% by dacha sayur, and the lowest accuracy achieved was 51.79% by ayam masak lemak. So next, we move on to the KNN classification result. So by using KNN, when the data was unbalanced, the highest accuracy obtained was 78.57% by ayam goreng berempah, whereas the lowest accuracy obtained was 41.07% by sup daging. So when the data was balanced using the oversampling method, the highest accuracy was 60.71%, which was achieved by sawi masak air, and the lowest accuracy was achieved by ayam goreng berempah, which was 48.21%. And by using the undersampling technique, the highest accuracy was achieved by dacha sayur, which was 67.86%, and the lowest accuracy achieved, which was by ayam goreng berempah, which was 42.86%. By using the ROS technique, the highest accuracy achieved was 57.14%. This was achieved by the food sample dacha sayur, whereas the lowest accuracy was 28.57% by ayam goreng berempah. And for the SMOT technique, in the KNN classification result, on the contrary, the highest accuracy achieved was 62.5% by ayam goreng berempah, and the lowest accuracy was achieved 42.86% by ayam masak kunyit. Next, we move on to the SVM classification result. By using SVM, when the data sets were unbalanced, dacha sayur, ayam goreng berempah, ayam masak lemak, and sawi masak air obtained the highest accuracy, which was 78.57%. Meanwhile, the lowest accuracy was obtained by nasi goreng daging, sup daging, and ayam masak kunyit, which was 57.14%. So when the data was balanced using the oversampling method, the highest accuracy achieved was 57.14% by ayam masak kunyit and sup daging, and the lowest accuracy achieved was 30.36% by the dataset from ayam goreng berempah. By using the undersampling method, the highest accuracy achieved was 66.07% by the food sample sawi masak air, and the lowest accuracy was 35.71% by the food sample ayam goreng berempah. For the ROS technique, the highest accuracy achieved was 58.93% by the food sample dacha sayur, and the lowest accuracy, which was achieved by the data set from the food sample ayam goreng berempah, which was 33.93%. And for the SMOT technique, the highest accuracy achieved was 71.43% by the food sample dacha sayur, and the lowest accuracy achieved, which was by the food sample ayam masak kunyit, which was 41.07%. And last but not least is we have the classification result for the random forest. So for the random forest classifier model, the highest accuracy obtained was 78.57% by the food sample data sayur and soy masak air, whereas the lowest accuracy achieved was 48.21% obtained by ayam masak kunyit. So this accuracy was achieved during when the data sets were unbalanced. So when the data sets were balanced using oversampling method, the highest accuracy achieved was 48.21% by the food sample nasi goreng daging, whereas the lowest accuracy achieved was 21.43% by using the data set from the food sample data sayur. So by using the undersampling method, the highest accuracy achieved was 64.29% by the food sample soy masak air, and the lowest accuracy achieved was 41.07% from the food sample ayam masak lemak. For the roast technique, the highest accuracy achieved was 57.14% by the food sample nasi goreng daging, and the lowest accuracy obtained was 39.29% by the food sample ayam goreng berempah. And last but not least is by the smooth technique, where the highest accuracy achieved was from the food sample data sayur, which was 75%, and the lowest accuracy achieved was 44.64% by the soup daging dataset. So in conclusion, this study, a simple electronic nose application was designed to identify and classify the level of the contamination in the leftover cooked food with machine learning through the order of the foods using local Malaysia lunch or dinner dishes that eventually ended up as stored leftover foods. And the samples were classified into two categories, namely fresh and spoiled. So the machine learning algorithm used to analyze the samples in this experiment were LDA, KNN, SVM, and RF, and additional techniques such as oversampling, undersampling, random oversampling examples, ROS, and synthetic minority oversampling techniques, MOD, were used to evaluate the classification accuracies due to the imbalanced data sets. And in short, we can see here for the unbalanced, for when the data was unbalanced, we can say the SVM gave the best classification rate based on the average, which was 69.39%, and KNN gave the least classification rate based on the average accuracies, which is 64.8. And for the oversample and the undersample, both KNN gave the best classification rate based on the average, which was for the oversample is 55.1, and for the undersample is 56.63%. And for the ROS technique, LDA gave the best accuracy rate, which form we can see in the average was 50.77, and for the SMOT we can see that RF gave the best classification rate, which with the average of 61.73%. And with that, I ended my presentation. Thank you.
Thank you, Wan. Any questions from the members? This is our final presentation, so we are ahead of time. Yes, you can expect many questions. Anyone? Just kidding. Just kidding. Wan, I think I missed out the your part where you do the experimental setting. Are you using a real leftover food for your experiment?
Yes, apparently yes.
Okay, so you have the leftover food, and then you have the sensor that you said you put in the you know
Plastic container, plastic container.
you put the food, okay, in the plastic container. All right. So this sensor can extract result instantly.
Yes, yes. I can detect the rate instantly in real time.
Okay. So no, meaning what I meant is that if I buy food from outside, I put it in a plastic container ke Tupperware ke, and then I have the sensor, so it can detect instantly.
Yes.
The category of the food, whether it's fresh or spoiled.
We propose a framework like that with the idea of to instantly detect if the food is still fresh or spoiled. That is
Okay.
this is the motivation for this research project actually.
All right. Okay. Are you in the process of developing such application? I mean,
Right now, we only for my masters until here, until the classification. Inshallah, I will further. Inshallah, I will further. So we'll develop the application. Actually, initially it was actually should be included in my masters, but due to the time constraint and the COVID and stuff, so that one we have to divide actually. So master stage until here, and PhD will later on continue. So more data
okay.
is expected to be collected for the PhD, inshallah.
Okay, yeah, but at least there's you have a ground to start, further of your work. Can you explain what is the difference between your, the unbalanced and the balanced data set? Just now, I don't understand.
So actually, my
What do you
data
mean?
it was unbalanced because for
Mm,
let's say there's a 300 rows. So for the fresh
okay.
data, we only have like 60 rows for certain food, 60 rows for certain food, 120 rows of fresh data, and
Mm,
then for the spot data, for certain is 240. The
mm,
remaining will be spot, and then for some food, the remaining the spot data will be like 180. So the unbalance actually caused the machine learning algorithm. There's inaccuracies there. So
okay. Mm,
as I said, so to balance it, we use that four technique. However, that four technique has their own disadvantages actually.
mm, okay. Seems that the accuracy that you have presented just now, it can be improved.
Yes.
Yeah, because it's quite low. So I'm sure there's a potential to be improved to increase the accuracy.
Mhm.
Any questions?
Um, I have a question. I
Go
was
ahead, Dr. Sarah.
Sure,
Yeah,
Dr.
I would like to understand. I want to understand about the unbalance and the rows. So, what can you conclude from there after you have? I understand that you are doing that because your data has some, I guess, imbalance, maybe some sparsity because of the odd number of data. I mean, information based on the category that you have. So based on the four things that you have done, those four sampling, so what can you conclude from there?
Based from the four techniques to balance my data set, I think my data actually because I done the categories were determined by observation. So my data obviously there is overlapping. So I think I can conclude from the accuracies is not high enough because there is overlapping between the data's fresh and spoiled.
Overlapping as in the category of overlapping, right?
Yes, yes, because when I actually analyzing my data sets, there were this value at fresh and then this value at the spoiled. So we try to actually, after this for the future work, we would like to separate the values into more categories because I'm planning to do fresh, semi sport and sport. So we try to do multi classification after this to see if it can improve using the same method but more labels. So to see if we can improve the accuracy in that sense.
Could it be because of the parameters that you set on your KNN, or maybe there are some parameter setting that you have done on your machine learning could have caused the sampling results?
I think for that, I haven't done any analysis on that, but it could lead to that problem also. It could be led to that problem also.
Oh, okay, okay.
Mm-hmm.
All right, thank you.
All right, thank you, Dr. Sarah. That was a good question.
Hi,
Yes, Dr. Rahman.
hi. I just want to ask. Yes, yes. I just want to add my experience
Mm-hmm.
dealing with imbalanced data set.
Okay.
So when you have the imbalanced data set, actually, if you do for classification, if you try to do some using the small the techniques that you presented just now, actually you will have the tendency to oversampling or undersampling. Okay, so when that kind of condition happen, it will actually result your model less accurate. So you need to check as well how what is when you apply with the method, what is the condition of your data set. So you need to check lah, yes, do some analysis, and then maybe you can combine the method in order to balance that.
I agree with Dr. Rahani actually, because I'm a bit skeptical on the sampling part. It could have, I don't know, overtrained or not undertrained, but yeah, undersampling somehow.
Yes,
Yeah.
yes, yes. It will result to that kind of situation.
Okay.
Okay,
Alright.
nice work.
The insight, Dr. Rahani.
Yeah, nice work. Nice work. Nice work.
Okay, thank you.
Okay, we still have time actually. 10 minutes to the closing ceremony. In fact, Dr. Alfred has posted the link to the closing ceremony. It's the same link to the keynote speakers link today. Okay, yeah. So before we go ahead to the main room for the closing ceremony, any more questions? For one? No? Okay, so if no more questions, thank you, Wan Nur Fadila. So yes, we will end this session. So you all can jump to the main room. Okay, thank you so much. Thank you, everyone. Yeah,
Thank you. Thank you, Dr. Masra.
you're welcome.
Thank you
Thanks.
for the insights and the question.
Thank you, Dr.
Yeah.
Masra.
Thank you so much. Thank you to all of you as well.
Why not
Okay.
we take photos? Take
Okay,
photos.
so takes photo. Yeah, the speakers for this session also have left. Okay, it's okay. Whoever is here, we can take photo. Who's gonna snap? Alfred, you gonna
Yeah,
snap?
yeah, yes.
Oh, okay, okay.
So we have Nosius, Wan Nur Fadila,
Yes.
Raihani. Oh, Dr. Farah left already. Okay. 1, 2.
So,
Okay, thank you. See you on.
welcome. Yeah, see you in the next room.
Yeah.
Okay.